Okay, we continue with the presentation of section 7. The topic is processing and recognition. We start with the paper relevance of sentences feature for multi-document text summarization using human written reference summaries that present Verónica Neri Mendoza. Go ahead.
Hello, my name is Verónica Neri Mendoza, and I am going to talk about the relevance of sentence features for multi-document text summarization using human written reference summaries. This work was carried out jointly Julia Ledeneva, René Arnulfo García Hernández, and Ángel Hernández Castañeda. Currently, there is an enormous growth of digital information causing overload. To manage this problem can be used natural language processing tools, particularly automatic text summarization. Automatic text summarization is classified according to the approaches in abstractive, extractive, and hybrid. On the other hand, according to the number of documents, there are single document text summarization and multi-document text summarization. In this work, we focus on extractive multi-document text summarization. Automatic text summarization involves create a summary by machine through a software to select the most important content from document source into a brief version. This process significantly differs from humans, since human can capture and relate words or topics. In this context, is necessary design cognitive processes of language comprehension to determine what sentences will form the final summary. In the state of the art, there was applied text features and syntax selection. Nevertheless, in each of them are some questions. And the first is what relevance each feature should have, and in sentence selections from text features, what sentences represent the document or the main idea. In the literature have been proposed several text features. It can classify in statistic features, deal with the distribution of words without understanding the document, while some of them are DF, IDF, positive keywords, inclusion of title words, and similarity with the main sentence into others. And linguistic features refers to using of linguistic knowledge to analyze the sentences. Some of them are inclusion of cardinal numbers, adjective, verbs, names of the places, and dates. There are different ways to calculate the relevance of text features. The first is the relevance based on the weighting from input documents. The next is the relevance based on coefficients, calculate through optimization, and finally relevates based on manual adjustment of coefficients. In the literature, have been proposed several data sets in order to evaluate the performance of the proposed methods. Uh, Commonly, they include human written summaries that help to compare a summary obtained through a proposed method with human skills. Usually, they data sets are under domain of news, such as Doug, Tag, and Multinews. In this work, we propose a method to generate extractive multi-document summaries. We use statistics and linguistic text features, and we hypothesis is that if we calculate the relevance of coefficients through human written reference summaries, we could improve the state of the results. In the proposed method, the first step is feature weighting to obtain the relevance coefficients for each feature from human written reference. So they are the input in this stage. After this, which were normalized, derived, type with part of speech and name entity recognition, vectorized with word-to-vec, and stop words were filtered. After this, we consider a set of statistic and linguistic text features, such as thematic words, tag words with tagged part of speech and name entity recognition, also TF-IDF, positive keywords, inclusion of title words, and similarity with the main sentence. In consequence, we create a feature matrix of sentence by features, and for each reference grades, for each human written reference summaries. After this, we calculate the sum for each feature, and after we compute the average in order to obtain the output, that is the vector of relevance coefficients W. In the second step,
piensa en esto. ¿Qué pasaría si un crack se fuera a vivir a tu casa por 5 días?
Hola a todos, bienvenidos a Lucho Soluciones. En este video vamos a estar hablando de
collection were concatenated in chronological order to form a meta document. After this, we apply a normalized, derived, tag with part of a speech and name entity recognition, vectorized with word-to-vec, and the stop words were filtered. To obtain meta documents normalized. These document normalized are the input for the next step. It is a feature extraction and sentence selection. In order to obtain the main sentences, we use a genetic algorithm, which initial population was randomly. We use binary coding. A gen is equal a sentence, so an individual represents a candidate summary. After this, we use the fitness function to maximize the weight of features. The features considered are the same mentioned above. And we create a feature matrix of sentence by features. After this, we calculate the sum to get a feature score vector, and from the vector of relevance coefficients calculated in the first step, we multiply the score vectors by relevance relevance of coefficients W, and we look for obtain the maximized value, and after this we apply the operators of selection, crossover, mutation, and we establish the stop criteria in a number of generations, and finally the output of the proposed method was the final summary. In order to evaluate the performance of the proposed methods, we consider the Duke-1 corpus. It consists in 300 documents if the entry collection is writing in English, and we consider the compression rate in 200 and 400 words, and we use a Roche system to evaluate. This is a system that compares the summary produced by proposed methods with ideal summaries written by humans using n-grams. In the experimental results, to compare the performance the proposed method, we consider the state-of-the-art methods that participate in Duke-1 computation and heuristics to obtain the benchmark. There are baseline first document, lead baseline, and baseline random. In the results, the proposed method improved over the state-of-the-art methods and heuristics considered in both lengths. The distribution of the relevance of text features, the summaries generated through the proposed method, the linguistic features were most relevant than statistic such as thematic works. In conclusions, the statistical linguistic feature modeling was performed from human written reference summaries. For extractive multi-document text summarization, the reference summaries written by humans usually only are used to evaluate the performance of the state-of-the-art methods, not to determine the relevance of text feature. And the results show that the proposed method improves sentence selection for extractive multi-document text summarization according to Roche 1. There are some reference, and thank you for your attention.
Thank you, Veronica. Someone, any question? Okay.
Hi. Can you go to the 17th slide? Okay. The GAA acronym is a genetic algorithm?
Yes.
Okay. And what is the difference, the main difference between your method and that genetic algorithm?
Okay. The main difference is that in genetic algorithm, with the proposed method, we calculate the relevance coefficients through from human written references. In this work, the coefficients of relevance are by adjustment, by manual adjustment.
Okay. Can you go to the slide where you are where you show your genetic algorithm? what are you representing with the binary coding?
A binary coding represents if a sentence will be included in the summary or not.
Oh, okay. And what is the length of your representation?
Is 0 and 1.
The length of the representation. The
And
length.
the length of the representation is according the length of the document, the document for input.
Okay. Okay. Thank you.
Thank you.
And any question from everywhere? Okay.
Okay, I get this side because of the speaker. Okay, what I didn't, thank you for your presentation. This is very interesting. But what I didn't understand is about the relevance coefficient. How is it measured? How you do, how the training texts they have a relevance coefficient between what and what, and how is it defined, the relevance coefficient?
The relevance of the coefficient computed through the proposed method are evaluated through the Roche in the, well, while summary generate is evaluated by this system. Not have a benchmark to compare with other form. Sorry, for compare with other form of calculate coefficients of relevance only is through a system evaluation Roche.
Okay, thank you. And as far as I understood, you use 19 features. I don't know. I saw a slide where there were 19 features, 19 dimensions. Why 19?
The rest of features that include in take words in by part of speech and name entity recognition, such as dates, verbs in base form and in the past form, places, names in the article are described.
Okay, thank you very much.
Everyone? No? No more question? No? Okay, Veronica, thank you. This is your problem. Thank you. Next, please. Continue with Jonathan Rojas Simon that present a classification of human and machine generated text using lexical feature and supervised and unsupervised machine learning algorithm.
Thank you very much. Good afternoon, everybody. My name is Jonathan Rojas Simon, and today I will start my oral presentation, which is entitled Classification of Human and Machine-Generated Text Using Lexical Features and Supervised and Unsupervised Machine Learning Algorithms. This work is a collaboration, has been done with a collaboration with Dr. Julia Ledeneva and Dr. René Arnulfo Garcia Hernandez. The content of my oral presentation is divided into the following subtopics. The first is the introduction. I present the topic of this paper, of this work. The next one is the background and related works. And after this, we present the problem of this research as well as the hypothesis. And the next one is we experimented with supervised and unsupervised machine learning algorithms. After this, we described the experiments and the obtained results. Finally, we explained some conclusions and future works. Currently, there are many large language models in the state of the art, which have boosted the research of cutting-edge applications, producing high-quality text according to the following criteria. For example, in terms of coherence, how the ideas of the text are well organized. In terms of fluency, how a text will be well read. In terms of grammaticality, how a sentence or a text is well written, and the language models produce real-world knowledge. In general, we can see that there are many language models. For example, as we can see, there are ChatGPT, Bloom, and Google Palm, and other language models. However, in the case of applications, large language models may be used to search information on the internet, and in other cases, we can create summaries automatically. However, these models can also be used maliciously. For example, they may spread untruthful news, reviews, or opinions. Therefore, these models may be used to manipulate people's interests. In previous works, in trying to detect human and language models generated misinformation, led to the following conclusion, that the content generated by language models provides more accurate information than human written text, but it shows more compelling disinformation. It was interesting in this work that led to make research about this problem. Therefore, the authentication task was proposed. Authentication, or also called automatic text identification, is a task to detect human and machine-generated text across multiple domains. Here we have many documents of different domains. And in the state of the art, several efforts have been done. Some of them have used or employed embedding features such as BERT, Roberta, Elmo, and other language models to detect language models of human written documents. On the other hand, we can see the use of advanced neural networks such as the short-term memory neural network, and they employed attention mechanisms that include the transformers. Therefore, most of these methods that employ these models have achieved state-of-the-art performance. As background and related works, many advancements have been done in this area. The first work in this context is Grover, which is a method to identify fake news, and also this method was used to detect machine-generated text or human-generated text. However, this method employed embedding representation from transformers, which led to this problem that we cannot explain how embedding representations are important in this task, the automatic identification of human or machine-generated text. In other cases, to make more explainable representations, the logistic regression algorithm was used with well-known text model representations, such as bag of words, and weighting with TF-IDF. However, it faces with high-dimensional representations, which led to heavier models. In this context, it is a challenging problem by the research community. And on the other hand, we can see that many datasets have been proposed in this task, such as RIU-ATD, which is a collection of scientific Russian documents. The DAGPAB 22, which is a collection of news articles, And the next one is the authentication dataset, which addresses two subtasks. The first subtask is given a set of documents. The challenge is to determine what document was generated by a human or by a language models. Here we have two tasks, human or machine. In the subtask number 2, which is called model attribution, given a set of documents, the challenge is to detect which document was created by a specific language model. In this task, we can see that many documents were generated by ChatGPT, Bloom, Palm, or in general GPT. So the problem of this research is how lower dimensional lexical features may perform with supervised and unsupervised machine learning algorithms to detect human and machine generated text. The hypothesis of this work is if lexical features of low dimensionality are used to differentiate human and machine generated text, they will be useful in creating reference classification and clustering models for more modern approaches. In this work, we propose the use of lexical features. In this case, we seek a lower dimensionality representation that can capture stylistic and lexical features from a document. Therefore, we calculate the probability that each character in ASCII format may appear in the document. For example, here we have the idea of this representation, where ASCII, the function ASCII of D, receives the input document in the D without any preprocessing. Each value represents the probability that a character may appear in D. That probability is calculated by dividing the frequency of the character in this case, a length of D represents the length of the document measured in characters, and the last value of 256 represents the probability value for unknown characters. In this case, we can see emojis and representations which weren't taken into account. In order, these features of that documents were used as inputs of machine learning algorithms. In the case of supervised learning, we experimented with multi-layer perceptron, logistic regression, and naive-Bayes. In the case of unsupervised learning, we employed the k-means clustering and the agglomerative hierarchical clustering algorithms. In order to compare the performance of the proposed representation and classification models, we employed the textification dataset, which consists of more than 55,000 documents dividing and training and test set. As we can see, the balance of these documents, of these sets, are well divided. Each document was written by humans and language models in 5 domains. For example, we can see documents of tweets, reviews, how-to articles, news, and legal documents. And the performance of the proposed representation or classification methods are evaluated in terms of macro F measure. In order to compare the performance and make our results more reproducible, we experimented with several parameters. In the case of machine learning perceptron, we employed an architecture of 5 hidden layers, each containing more than 300 neurons on each hidden layer. And we employed the ReLU activation function in hidden layers and the sigmoid function in the last layer, in the output layer. In the case of logistic regression, we employed the default parameters that were provided by the scikit-learn Python library. In the case of a naive-Bayes algorithm, we experimented with many variants. However, we selected the multinomial naive-Bayes because it obtained the best results. In the case of k-means clustering, as the task requires the classification of documents into 2 classes, which is human and generated, the k-means clustering algorithm operated with k equals 2. And finally, in the case of agglomerative hierarchical clustering, we use the Euclidean distance to measure the separability between patterns and clusters. And then we create two clusters setting the distance value to 8,000. And the obtained results, we can see that according to the F measure, we can see that the naive-based algorithm performs best in comparison to the remaining algorithms. In other cases, we can see that multilayer perceptron and logistic regression perform similar in this measure. However, the multilayer, we saw that the multilayer perceptron performs well in classifying machine-generated text, and logistic regression performs the opposite. It was a method to classify well human-generated text. And in this comparison, and in general in the paper, we see that the proposed representation will be the basis of more modern machine learning algorithms. In order to compare the performance of the proposed representation with other state-of-the-art methods and baseline methods, we compared with the following baseline approaches, which were provided by the authentication task. Some of these baseline use well-known representations and models. For example, they use bag of words, logistic regression, a random assignment of tags. In general, they use some of these baseline approaches use the transformer architecture. On the other hand, we can see the state-of-the-art methods. In particular, these methods are employed representations based on GPT-2, GPT-3, and BERT. And they obtained the best results in the task. In this table, in this comparison, we can see that the naive-based algorithm performs best in comparison to the baseline approaches. It is interesting because we only use lexical features, 256 features. However, it is still far from the best results. For example, the best result of this task, it is the highest possible value at the moment. However, we didn't wanted that the proposed representation would be the best. However, this is a good beginning to make more modern approaches or more modern representations. As we expected, unsupervised algorithms perform lower than supervised approaches. In order to conclude this presentation, it is important that we explore and analyze the performance of supervised and unsupervised machine learning algorithms using lexical features, which were based on the ASCII format and the probability of characters that appear in each document. These features have been used as inputs to supervised and unsupervised machine learning algorithms, such as multilayer perceptron, logistic regression, naive-based, K-means clustering, agglomerative hierarchical clustering. According to the obtained results, the naive-based models based on multinomial distribution of text features performed best in the task. Compared to the baseline approaches, it provides a better classification between manual and machine-generated text. And finally, as feature works, we focus on more advanced classifiers, such as the LSTM and transformers. Of course, we are including other features, which are based, for example, in text complexity. Moreover, we seek the implementation of more advanced and explainable text features. Those are the reference of this work. And thank you for your attention. Thank you for listening. If you have any questions, please write me an email. Or in other cases, you can see my Google Scholar profile to see what kind of works we have done in this research group. In other cases, you can see in this QR code some developments stored in the GitLab platform. Thank you very much.
Thank you for your presentation, Jonathan. Anyone has a question? Okay, Clemente.
Hi, I have two or three questions. The first one is, why do you use unsupervised algorithms when you have labeled text?
In this case, in this paper, we employed unsupervised machine learning algorithms in order to compare or will be the basis. So if we use this representation with unsupervised, what will be the performance? So that was our first approach. In this case, we observed that we obtained the lowest results, as we can notice, and in general, it was to make a broader comparison. We include supervised and unsupervised.
Okay, well, I think supervised algorithms are very useful to exploring the clusters of when you represent your data set with different text representations. I think, and I suggest you to use a different vision of why you are using unsupervised algorithms, I think.
Okay.
And the second one is, why do you use character counting instead of word counting or even another weighting scheme?
Okay, we employ the frequency of characters because we expect that this representation will be used in other languages, in other domains, in other tasks. And this is our initial motivation to make this representation will be useful in other tasks without importing yes, without the necessity of employing dictionaries or other lexical or language resources.
Well, and why do you say that you are using lexical relations, lexical features? And I didn't see the lexical features. Where are they?
Okay, lexical features in this context, we employ how, for example, a person writes a letter, the frequency of how much times a person writes a letter, a vowel, or a punctuation mark. And in this case, we were based on that lexical features.
Okay, thank you. We need to talk.
Yes.
Thank you very much. I think it's a very relevant subject because LLMs are quite very intensive in their processing. I think that we could help. One of our hypotheses is that we can help the LLMs if we include lexical, syntactical features because the number of valid structures, well-formed formulas in any language are limited. So I think it's a very relevant approach. And I just wanted to say this, and I think that after the session, we would like to keep in contact with
Okay.
you. Thank you very much.
Thank you. Thank you.
Okay, more question or comment? Oh, okay.
Hello. Well, first of all, congrats for your presentation. Really interesting, and I agree with the professor. It's a really interesting work. So, can you change the slide to number 11, please? I don't know if I get a little bit lost, but why are you using the tweets, the reviews, how-to articles, news, and legal documents? Is there a justification for that, for using those?
Yes, in this case, our justification addresses many domains because, for example, if we use a tweet or if a language model creates tweets or very short length, In other cases, we can see that in the case of the news domain, the documents are larger, of course, and therefore it is very difficult to detect who created a news or a tweet or how-to articles, and that is the most challenging. This is the most challenging feature in this task because if we use tweets, there are specific features, specific relations that we can explore to obtain a better discrimination of documents.
Okay, interesting. And the second question is, why do you think that naive bias achieve better results than the other ones? I'm curious about that.
Yes, in this case, we experiment with several algorithms. However, it impressed us that the naive-based algorithm performs best. In this case, we can see that the probabilities of naive-based algorithms may be a good approximator or maybe a good suitable representation using those features. In other cases, we can see, for example, in the case of multi-layer perceptron, we use only 5 layers because we obtained an overfitting, and it was not a suitable representation or model, classification model. Thank you.
Okay. Anyone? No more question? Okay. Thank you, Jonathan. This is your different. Thank you. Okay. The last presentation of this session, speaker is Maria del Carmen Garcia Galindo with the presentation is identification of deceptive tests using cascade classification.
Hello, good afternoon. My name is Iris Maria del Carmen. I am a student at the Autonomous University of Mexico State. Today I present my research titled Identification of Deceptive Text Using Cascade Classification. This research is in collaboration with Dr. Angel Hernandez, Rene Garcia, and Julia Ledneva. Online reviews, also known as textual reviews, is a writing assessment or opinion about the product or service. In the digital area, this type of text play an important role for both buyer and seller because this type of text provide value information they are considering pushing to make informed decision. On the other hand, this type of text significantly impacting the reputation and sales of the product or service because according with different studies, many people prefer to buy products with positive reviews. The textual reviews allow consumers to openly express their opinion, share experience, thoughts, emotion in another factor. However, another is free to write a textual review. This can lead to negative consequences, such as insult, spam, or deception. Deceptive texts are those texts don't reflect the genuine experience or opinion of the consumers. In this sense, some deceptive texts try to make a product or service seem better than really is, that done more than its product. On the contrary, other deceptive texts try to make a competition product or service seem worse, with the objective is damage the image of the product or service and reduce your service. In the literature, it's mentioned that the diversities companies incentivize other people that the publication, the deceptive text. Therefore, no all deceptives are genuine. The task is the identifying of deceptive text generally consists in determining which text is genuine or deceptive according to the words used. However, among currently information has become more complex tasks. For this reason, it requires the combination of different filters, for example, lexical, semantical, emotional, and another filter that provide clues or clues associated with the deceptive act. In this regard, the job of designing a charm combine different filters. In this job, the author considered the study of the unigrams, part of the speech, sentiment polarity, and specific emotion. And the author used the support vector machine. The objective is identify authentic or deceptive author reviews. The author concludes that the combination of the unigrams with emotional aspect create a more complete set to provide the identification of deceptive text. Other job is the Hernandez Castañeda. In this job, the author analyze the impact of polarity of deceptive text. In this job, the author generate a subset of positive or negative opinions. In this study, also the author concatenate information lexical and filter to training the Naive Bayes algorithms. The author concludes that using lexical information achieve acceptable results because adding the polarity information works as performed. However, in this study, the author proposed a future job, the analysis of different emotions, not only the polarity, because the analyze the different emotion allow more aspects, not only to classify. In the job of the Garcia Galindo is proposed on a cascade classification method to detect signal of suicidal ideation in text by identify latent emotional distribution. This method is characterized because used two classifier. The first classifier identify the emotional distribution, and therefore use this emotional distribution to identify the class of the membership of the text. In this method, don't direct analyze direct words related to the suicide. The class membership is determined with the emotional distribution. Currently, the pre-entrained large language model are the subject of great interest in different research for different topics. In this regard, RWAL comparative the performance of different, for example, the between long short-term memory, gradient both strip, and bidirectional encoder representation for transformer as to know about. The objective was identify which new is fake or real. The results show the defined Turing model achieved the best accuracy. Currently, in the computational area, several approaches have been developed to identify deceptive text. These approaches have been developed to automate and improve these tasks. This approach have employed a variety of future methods, machine learning algorithms, and more recently, the large language model. Therefore, this study proposed a cascade classification to identify deceptive text. The slide shows a general overview of the proposed method. The first step consists in the weighting of terms in which each text is converting a numerical vector. Then the first classify and analyze this information to The objective is identify the probability distribution of different emotion. Next, the emotion probability, the vector of distribution of emotion are concatenated with lexical feeder. Finally, the second classifier use this vector concatenate with lexical and emotional feeder to determine which text is deceptive. In this point is important, irrelevant mentioning that in this study we employ an I-bias classifier, support vector machine, and multi-layer perceptron. This classifier were employed with the Pauli hyperparameters according to the Sky Learning Library. The evaluation for the evaluation models, we employed the phi cross validation. The metric used in this study was precision, accuracy, and FA1 measure. One of the proposed objective in this study is determine which the emotion, the distribution emotional present in the deceptive text. For this objective, in this study, we use the WASA. WASA is a collection with different sentences labeled in a specific emotion. The emotion considered in this collection is anger, fear, joy, and sadness. In order to evaluate the performance of the proposed method, we use three different data sets about the deceptive or genuine text. The first is the deception in reviews. This collection consists in deceptive and truthful box reviews from Amazon. The second is the opinion spam. This collection consists in reviews about the different hotels from Amazon and TripAdvisor. This data set is considered the unsanctioned deception because the people who raised this text were paid to lie. And finally, data set study in this proceed is the opinion on controversial topics. This collection consists in different opinions about the three topics. The topics are abortion, death penalty, and bed experience. This collection is also considered the unsanctioned deception because the people receive the pay to lie. This table shows a statistic of the purpura use in this study. In this study, also we compared the analysis of different feeders. For example, analyze the lexical, semantic, and contextual feeders. For this purpose, we use different methods. The one who recognize the TF-IDF were used for the lexical analysis of lexical level. LDA and Octubek is a semantic level, and BERT is a semantic and contextual level. In this study, a specific use this BERT based on case. According to the experimental result, we study mainly compare two approaches. The first is the baseline proposed approach. The baseline refers to the approach with the use the distribution and emotion latent. On the proposed method is deferred to the baseline because in the proposed method the distribution emotion are concatenated with lexical feeders. In the case of classifier the DevRep, the proposed method achieves the best result. This result shows that the incorporation of lexical feeder adding to the emotional distribution improves the classification process. In the classification of the span, saying the proposed method achieves the best results in comparison with the baseline. In this classification, reinforce the effectivity of proposed approach in the classification intentional deceptive reviews about the hotels. Also show that extracting latent emotion from text using semantic contextual analysis improves the classification. This type of user is obtained to the bird. In the classification of the reviews about the abortion, the best perform is obtained with the baseline. It's important mentioning that the abortion is a small data set. For this reason, the results show that in a small data set don't require analyze additional feature to discriminate the deceptive text. Finally, in the deep penalty, the baseline obtained the best perform, but in both cases, the semantic, features with semantic level are used for the best classification. In the base friends, the proposed method achieves the best result. In this case, are used the contextual and semantic filter to achieve the results. Overview, the proposed method achieves the best result in comparison of this collection analyze. This table that we conclude that the BERT is a good method to analyze the contextual and semantic information because achieves two of the three the best results. With the conclusion, we obtained that the cascade classification method, which combined with lexical and emotional filter, perform the approach that they only use the emotional distribution. Other conclusion is that the BERT emerged the filter vector method with the best perform. The proposed approach does use a large amount of resource at advanced model do. That is the case of the BERT. And the proposed method also conclude that in this study show a good performance in different data sets with different topics. This approach also compared two different future methods, different algorithms. It's all. Thank you for your attention and waiting for your questions.
Thank you, Maria del Carmen. And anyone has question? Okay. Thank you, Memo.
Sorry, it wasn't me. Thank you for your presentation, Maria Carmen. The application of these methods are limited to some fields, only some fields, abortion, death penalty, those that you mentioned. But how far maybe you of using in a more wider context? I don't know, for example, reading opinions in Airbnb about some places, some hotels, houses, apartments. You can find some relevant information, and we as humans we can distinguish, we can identify which opinions may be more valuable to make a decision or about some product that you find in Amazon or any e-commerce site. So how far can you be of being extending this work for a wider for other fields, not only those that are identified? Thank you.
This approach,
I don't know if I expressed myself or can I try to?
can you repeat your
Sure, no
or-
problem. Okay. As far as I understood, I hope I understood well, these methods are applied on specific fields, on specific topics, abortion, death penalty, and you take some information about emotions to define if a post, if a text is real or is deceptive. Is that right? Okay. And I was wondering how far can you be to extend to other topics this kind of methods?
Um, the advantage of this proposed method don't depend of the specific words that identify, for example, deceptive text associated with the abortion or other topics. This proposed method is more relational with the emotional distribution. The emotional maybe don't explicit express. This propose allow identify this emotion and they don't express implicit. For this tutor, this method is possible used in other contexts.
Okay, so emotion is a crucial factor to decide if a text is deceptive or not. Is that right?
Yes, the
Okay.
emotion is an important tutor for this proposed method. For the emotion can be is varied depend of the topic, but is for this tutor is possible adapt to the sample of the others detection of the other type of topics.
Thank you very much.
Any question or comments? No? Okay. Thank you, Maria del Carmen. This is your diploma. We are having a break for lunch and continue the presentation at 3 p.m. Please. Okay, thank you.